What's going on, guys? Let's do this problem right here. This question is asking to find the remainder of this first degree polynomial. Let's see how we can do this. This is our generic equation, and what we are going to do is we are going to replace this n value with the degree. Since we have first degree, we are going to replace all the n values with first degree. And if you replace this one, you can see that this is our derivative part, right? And here we have to find derivative. So if you plug 1 right here, this is going to be 1 plus 1, that's going to be 2. So we have to find second derivative of this function. So that's the only thing we have to find to plug back in this equation and find the remainder. Now let's go ahead and find the derivative. First of all, we have this one right here. So let's write this one as 1 plus x square power half, because if we have square root, it's same as half, right? So we can write this one as 1 plus x square power half. Now if we take the derivative of this one, f prime x, this is going to be half times 1 plus x square, and then we subtract 1 from the power, that's going to give us negative half, and then we have to take the inside derivative. This is going to be chain rule. Whenever we have bracket and we have function like this, that's going to be chain rule. So we have to take the derivative of this one, that's going to be 2x, right, 2x, and if you multiply this one by the front value, that's going to give us just x, because 2 cancels, and we are going to left with x times 1 plus x square power negative half. Now we have to take the second derivative, and if you notice that we have x right here and another x function right here, so we had to use the product rule. We had to use the product rule to find the derivative. Now let's go ahead and find the second derivative. The second derivative for this one is going to be, so when we take the product rule, first of all we are going to find the derivative of this one and keep this one as it is, and then we find the derivative of other one and keep this one as it is. So here if we take the derivative of x, that's going to be just 1, and this is going to be remaining the same. So this is the only thing we are going to have in the first one. So this is going to be 1 plus x square power negative half, and then we are going to have this one remaining as it is, just x, and if we take the derivative for the one, this is going to be negative half in front, and then we are going to have 1 plus x square power minus half minus 1. So minus half minus 1 is same as minus half minus 2 over 2. So if you subtract this one, this is going to give you negative 3 by 2. So this is going to be our power. And then if you take the inside derivative, this is going to be 2x. And we can also simplify this one. This 2 cancels, and we are going to have negative x square in front. So let's simplify this one. This is going to be 1 plus x square power negative half plus this 2 cancels. So instead of writing plus, I can write negative in front. So this is going to be negative, and 2 cancels, this x multiplied by this x, and that's going to give us negative x square. And this is going to be x square times 1 plus x square power negative 3 by 2. Now we have this one. Now in order to simplify this one easily, what we can do is we can take the negative 3 by 2 common, and if you will notice that what will happen if we take that. If we take this negative 3 by 2, 1 plus x power 2 negative 3 by 2, in the bracket we are going to have this one, that's going to be 1 plus x square power 1. And you can see if you multiply this one again, you will get negative 1.2 back. If you add this one, negative 3 by 2 plus 1. Plus 1 is same as 2 by 2, right? And if you add them together, that's going to give you negative 1 by 2. So if you take this common, this is going to be this value. Now in the other side, we are going to have x square. The reason we took this common value is because if you notice that this x square and this x square cancels each other, and we are only going to have 1 right here, and this one multiplied by this one, that's not going to change anything. So this is the only thing that's going to remain, We can also write this one as 1 over 1 plus x square power 3 by 2, right? Now we have found the second derivative. Now all we have to do is replace this equation with this value, second derivative. Now before we go and do that, we have to write this one in terms of z, right? So all we have to do is replace x value with z value. So let's go ahead and do that. This is going to be, so f double prime z is going to be equal to 1 over 1 plus z square power 3 by 2. So this is going to be our second derivative. Now we can go ahead and write our final answer. Our final answer is going to be, so let's trace this part. So our final answer is going to be this one on top, that is 1 over 3 plus, actually this is 1 plus z square. This is z, right? Z. So this is going to be 1 plus z square power 3 by 2 times x minus c. So x minus c. So this is, here we have c1, right? So this is going to be just x minus 1 power, this is first degree polynomial, so we are going to have 1 in the n value. So this is going to be 1 plus 1, that's going to be 2. So this is going to be 2 right here, and in the denominator we are going to have 1 plus 1 factorial, so that's going to be 2 factorial. Now we can bring this one down. 2 factorial is basically 2 times 1, that's going to be just 2. Now we can write this one in simplest form. So this is equal to 1 over 2 times 1 plus z square power 3 by 2 times x minus 1 square, and that's going to be the final answer. I hope you guys find this video helpful. See you next time.